Hi guys, today I want to talk to you a little bit about the Qumran sundial. And what you'll see here is a picture of it. This is a replica. It was made by a company here in the States. But if you look at it closely, basically what it is, you first notice two separate circles with notches in them. And we're not going to describe the whole thing today, but I want to point out to you how it calculates the solstices and the equinoxes, which is the most important part of that kind of a calendar. It does several things actually. But first, there would be a stick in the center, which is the hole in the center, and that would mark the shadow of the sun. The first thing I want to draw your attention to, though, is that there's actually, or would be, 7 circles on this. The original one, or a few that they found, there's actually another layer of a circle with notches on the edge, and you can't really see the edge too well. But notice on the right-hand side, right here, you have this marker, and it's kind of odd. It's not normal with the other markers in the circle. And this marks special things. It points to 2 separate places. So looking at it real careful there again, you can see how it comes out, and it marks 2 circles that are special circles in here. And so going on, if you look at this first one here, if you draw a real thin line, you'll notice that it's marking the edge of that first circle that has the notches in it, so that outer edge. Okay, and then the smaller one, or the other one there, actually marks the smallest circle on the dial. And so this circle here is the equinox circle, and that's the most important one that we want to look at, because the spring equinox always starts their year, and that's how the calendar basically works. This one is actually the summer solstice one. So just remember, during the summer solstice, the sun is the furthest north, and so any shadow we have is going to be smaller. Winter solstice, it's the furthest south, so any shadow we have is going to be the longest shadow, and the equinox is going to be right there in the middle. So let me show you what that would work. On the summer solstice, you would have the smallest shadow, and so this is what the shadow would look like. So what marks that very first circle? So that first circle is the summer solstice. That would be June 21st, first day of summer. 1 month later, you would have July 21st. So it's 1/4 into that season. So 3 months per season. So at this point then, this is June 21st, this would be July 21st, August 21st, and then finally you hit the equinox circle at September 21st, which is the fall equinox. And then we keep going. The next one would be from September would be October, and then November, and then December. And again, you can't see that outer ridge, but that would be the farthest out. So that would be the winter solstice. At this point, the sun would start coming back north, and so the shadows would get smaller. So this would be July 21st, and then February 21st, and then finally back to March 21st. This would be the spring equinox. This would be the most important part of the year for them. So that center circle, the outer edge right here, is the most important part of calculating how the year works. But then, of course, it would keep going, and you would go from the spring equinox at March 21st to April, and then May, and then finally back to June 21st, which would be the summer solstice, and the entire thing would start over again. So this is one part of the sundial and how it works. And the interesting thing about it here, so you have enough lines here to mark every month. So there's 6 months out, 6 months back, so 12 months of the year, solar months. If you made this twice as big, this is only about 6 to 8 inches, but if you made this 2 to 3 times bigger, you could actually double the lines and count the 2-week periods. Okay, and then if you double the lines again, made it maybe 4 feet, you could very accurately show the weeks, so the 52 weeks of the year. You'd go out 26 and then come back 26. And if you made a really big one, really precise counters, the you could possibly take each one of those, divide it into 7. So then you'd have the 364, 65 days per year and be able to calculate the days. Not necessary most of the time, but these are pretty important. That's actually what the old Gilgals were. Gilgal is a Hebrew circle of standing stones. And those would be kind of like Stonehenge, you know, something really big like that where you could calculate each one down to the day, and then maybe even look at calculating other things like stars. So these are really big calculators. But I want to show you as an example here. We'll go back, this is the sundial, but here's a picture, a GIF that someone made of Aztec sundial. Now this is in the southern hemisphere, so the summer solstice will be our winter solstice. But as you can see, when you're in the center is the equinox, and now we're getting to June, which would be our summer solstice, their winter solstice. Then it would begin to come back. And here is the equinox. And then notice they divide it into 5 pieces rather than 6, so it's different. But there's the summer solstice, it'd be our winter solstice. And then eventually comes back to the center, and the center would be the equinoxes. So there's our spring equinox and their fall equinox. So this is dividing it into 5. You could subdivide it into different ways. Now, if you made this where that thing was very clear and was at least 2 or 3 times further back and further and much bigger, you could double the size in it, so you could see multiple things. So this is dividing it into 5 pieces instead of 6 months. Here's another example of one down in Peru. Now notice we start at the solstice, and each month is going every other notch. So that's a great example of somebody that made one twice as big. From this vantage point, you go from the solstice, 1 month, 2 months, and the 3rd month is the equinox, 1 month, 1 month, and then the solstice. And then you keep coming back. But notice it's skipping 2. So this would actually mark every 2 weeks. So again, if you double this again, you could have something that marks every single week or every Sabbath, for instance, that kind of a thing. So that's a really great example of these kind of things. So this has been a small study of the Dead Sea Scrolls sundial found in Qumran. Mainly we're just looking at how it marks the months, and specifically the spring equinox, which is the beginning of the year for them. So we'll come back and do other studies on this and the calendar at a later time. God bless.